Gears as torque converters. I is equal to output torque divided by input torque. So I is equal to M2 divided by M1 is equal to D2 divided by D1 is equal to R2 divided by R1 is equal to Z2 divided by Z1 is equal to N1 divided by N2. So M1 is equal to F times R1 and M2 is equal to F times R2. So M2 is equal to M1 times transmission ratio times efficiency. So M1 is equal to input torque, M2 is equal to the output torque, we have the efficiency, then I is equal to transmission ratio. Example 1. The transmission ratio of a gear drive is 3.5:1. The input torque is 6 Nm and the total efficiency is 98%. What is the output torque in Newton meter? Given the following, I is equal to 3.5:1, M1 is equal to 6 Nm, efficiency is 98%, M2 is equal to M1 times I times efficiency. Multiplying through, we have M2 is equal to 20.58 Nm. Example 2. A driven gear wheel with 65 teeth has a torque of 40 Nm. What is the torque in Newton meter of the driving shaft if the driving wheel has 39 teeth? Given the following, Z2 is equal to 65, Z1 is 39, M2 is 40. So I is equal to Z2 divided by Z1. I is equal to M2 divided by M1, making M1 subject of the formula. M1 is equal to M2 divided by I. Substitute the values, we have M1 is equal to 24 Newton meter. Example number 3. A flat belt is subjected to a tension of 600 Newton. The ratio between the diameters of the two pulleys is 3:2. The diameter of the driving pulley is 141 mm. Calculate the torque in Newton meter. Given the following, F is 600 Newton, I is 3:2, D1 is 141 mm. I is equal to D2 divided by D1. Therefore, D2 is equal to I times D1, which will give us 94 mm. M1 is equal to F times R1. So substituting the value for R1, which is D over 2, we have M1 is equal to 42 Newton meter. M2 is equal to F times R2, where R2 is equal to D2 over 2. Substituting the value, we have M2 is equal to 28.2 Newton meter. Example 4. A double gear drive with an initial revolution speed of 185 rpm has component transmission ratios of 2:3 and 3:5. Calculate the initial torque in Newton meter if the final torque is 65 Newton meter. Given the following, N1 is 185 rpm, I1 is 2 over 3, I2 is 3 over 2, M2 is 65 Newton meter. I is equal to I1 times I2. Substituting the values for I1 and I2, we have I is equal to 2 divided by 5. Also, I is equal to M2 divided by M1. Therefore, M1 is equal to M2 divided by I, which will give us M1 is equal to 162.5 Newton meter. Example 5. The initial torque of a gear drive is 65 Newton meter. The torque is transmitted via a 40 gear wheel, a 24 idler wheel, and a 62 gear wheel. Calculate the final torque in Newton meter. Given the following, M1 is equal to 65 Newton meter, Z is equal to 24, Z1 is 62. Note, the idler has no influence on the torque. M2 divided by M1 is equal to Z2 divided by Z1, making M2 subject of the formula, and substituting the values, we have M2 is equal to 100.75 Newton meter. Example 6. What is the peripheral force of a driving wheel with pitch diameter of 160 mm if the component transmission ratio are 1:4 and 2:3, and the final torque is 45 Newton meter? Given the following for I1, I2, M2, D1 and R1. So I is equal to I1 times I2, which will give us I is equal to 1/6. So if I is equal to M2 divided by M1, making M1 subject of the formula, we have M1 is equal to M2 divided by I. Substituting the value for M2 and I, we have M1 is equal to 270 Newton meter. So from the equation, M1 is equal to F times R1, making F subject of the formula, we have F is equal to M1 divided by R1. So F will give us 3375 Newton. Example 7. A motor has a torque of 140 Newton meter. The efficiency of the gear system is 90%, and the torque of the output shaft is 1512 Newton meter. What is the transmission ratio? Given the following M1, M2 and efficiency, M2 is equal to M1 times I times efficiency, making I subject of the formula, we have I is equal to M2 divided by all in bracket M1 times efficiency. Substituting the values, we have I is equal to 12:1. Example 8. The number of revolution speed of an idler wheel with 30 teeth is 350 rpm. The driven gear wheel is to have a revolution speed of 125 rpm and a torque of 10.5 Newton meter. The driving wheel has 40 teeth. Calculate the initial torque. Given the following Z, N, M2, Z1 and N2. N over N1 is equal to Z over Z1, making N1 subject of the formula, and substituting the values, we have N1 is equal to 262.5 rpm. I is equal to N1 divided by N2. Substitute the value for N1 and N2. I will give us 2.1:1. I is also equal to M2 divided by M1, making M1 subject of the formula, we have M1 is equal to 5 Newton meter. Thank you for watching. Stay blessed.